All right, so this is a summation proof or a summation rule that we had seen earlier, and now we're going to actually prove it to be true. So we're proving that the sum of square numbers is equal to n over 6 times n plus 1 times 2n plus 1. So let's see what that looks like. So this is my p sub n statement, and I'm going to treat this as my left-hand side and this is my right-hand side. So there's my p sub n. So p sub 1, let's show that to be true. So 1 squared is equal to 1 over 6 times 1 plus 1 times 2 plus 1. That is true. So now assume, and it's really important that you're always writing this word, assume p sub k to be true. So that is 1 squared plus 2 squared plus 3 squared all the way down to k squared is equal to k over 6 times k plus 1 times 2, that's not so nice, 2k plus 1. And now we're going to let n equal k plus 1. So what we want, so I'm always going to think about what I want over here on the side. 1 squared plus k squared plus k plus 1 squared equal to k plus 1 over 6 times k plus 2 times 2 times k plus 1 plus 2. Well, that's going to be 2k plus 3. So this is what we want. So the left-hand side is going to be 1 squared plus 2 squared down to k squared plus k plus 1 squared. As always, I'm going to substitute in my p sub k statement. So k over 6 times k plus 1 times 2k plus 1. And I'm going to add in my k plus 1 squared. To make my common denominator, I'm going to make 6 over 6. And now, because I know that in the end I want something that's factored, I'm actually going to think about factoring because I have a k plus 1 here and a k plus 1 here. I have 1 over 6 in each of them. So I'm going to bring out 1 over 6 times the k plus 1. So then this left term, I've got a k left and I've got a 2k plus 1 left. So k times 2k plus 1. On this side, I took out a 6, I took out a k plus 1. So I've got 6 times k plus 1 left over. So I'm going to keep going with my left-hand side. I've got k plus 1 over 6. Putting that together, which is good. I wanted that. Now I've got 2k squared plus, that's going to be plus k here, plus 6k here, so that's 7k, and then plus 6. And sure enough, that's going to give me k plus 1 over 6. This is going to factor into k plus 2 times 2k plus 3. So just a quick check, 2k squared, 3k and 4k make 7k, and that gives me my 6 equals the right-hand side of the p sub k plus 1 statement. And then I'm going to write my conclusion. So let me just put in a text box. Since the statement is true for n equals 1 and proven to be true for n equals k plus 1, assume by induction the statement is true for all k greater than or equal to 1.